What's in this thing?
I recently managed to get 3 Western Digital Raptor hard drives. The Raptor line of hard drives from Western Digital were first released in 2003. They were the first consumer 10,000 RPM hard drives and quickly became popular in PC gaming and enthusiast communities for the additional performance over traditional 5400 or 7200 RPM drives. I have 3 of the 74 gig models, 2 WD-740 ADFDs and a WD-740GD, which has been refurbished after release by Western Digital. They are all from around the same time period, 2007. At the time of launch, they were around £100 each. Today I plan to see if they can hold up against a cheap modern SSD. I'll be using the SSD in my test rig, a Crucial BX500 240GB. At a cost of only £25, it makes a Raptor drive look even more expensive. Now I know that mechanical hard drives can never reach the kind of performance of an SSD, even a cheap one, and especially not an NVMe SSD. However, a RAID 0 configuration should allow the PC to write to all the hard drives simultaneously. First, let's test the SSD to establish its performance under different workloads. I'll be using Crystal Disk Mark, ATTO Disk Benchmark, and HD Tune 2.55 to test the drives. For Crystal Disk Mark, I've decided to use the default settings and just change the file size that it uses to test the drives. I'll be using 16 MB, 1 GB, and 32 GB. We'll mostly be focusing on the SEQ1M Q1T1 and the RAND 4K Q1T1 tests, as they correlate well to real-world performance. The SSD performs as expected, with read speeds reaching around 525 MB a second and 470 to 480 MB a second in the writes, with the exception of the 32 GB file where it dropped to 135 MB a second writes. I ran the test a couple of times and got similar results each time, so maybe it's just a limitation of the drive. The random 4K test gave much lower results but still managed 22 to 36 MB a second reads and 30 to 72 MB a second writes. Now the ATTO Disk Benchmark results. This involved a series of read and writes at different file sizes. The SSD suffers at lower file sizes but quickly reaches its rated speeds when files increase, with a few exceptions which I assume is related to caching on the drive. Finally, the HD Tune run. This version of HD Tune is pretty old now, 2008, but still should give us an idea of performance. With a minimum transfer rate of 283 and a max of 407, it's slightly under spec, but I'm not exactly sure how these tests are performed, and the rated speeds do use Crystal Disk Mark with a Q depth of 32, which may not be in use here. Finally, the access time is a cool 0.1 milliseconds. Before we test the RAID array, let's see how the drives perform individually. The age of them will have degraded the performance, and 2 of them are being powered on for over 44,000 hours. However, they are still 10,000 RPM drives, so I expect them to be okay-ish. The 2 WD-740 ADFD drives perform very similarly, with read speeds maxing out around 100 MB a second and averaging around 80 MB a second, until we reach the random 4K tests, where the limitation of a physically moving read head is obvious and speeds drop massively. The other Raptor drive, the WD-740GD, appears to perform worse, with speeds maxing out around 70 to 75 MB a second, but dropping as low as 0.22 MB per second in the random 4K tests. This is probably because, even though this drive has a manufacture date of 2007, it was first released in 2004 and uses a parallel ATA to serial ATA bridge. It also lacks native command queuing and instead uses tagged command queuing, which is a less efficient version and requires more CPU overhead and CPU interrupts, lowering the performance when many read or write commands are queued. Now that we have an idea of how the drives perform, let's try implementing them in a RAID scenario. I'm going to be using the motherboard's RAID functionality. Here I've made a RAID 0 configuration of the 3 Raptor drives, called Raptor. I'll get Windows installed and we'll see what performance it can achieve. I'll be running the same benchmarks again to assess the speed of the RAID array. First, the Crystal Disk Mark test. The SEQ1M Q1T1 run managed 210 to 215 MB a second reads and 205 to 216 MB a second writes. It's beaten by the SSD in everything apart from the 32 GB writes, where it exceeds it. I'm not exactly sure on why, and I ran it a few times to make sure it wasn't an error, but it seemed consistent. Where the drives really suffer is the random 4K test, with the exception of the 16 MB files. This is probably because the drives have a cache that holds the file before it's written to the actual disk, booting the read and write speeds here. Once the file size increases to 1 GB and then 32 GB, then the limitation of a mechanical hard drive is obvious. The speeds are much better than when the drives were separate but never even reached double-digit read or writes. The drives are also very loud when performing these tests, as each drive read or write head is moving rapidly. Next, the ATTO Disk Benchmark test. This performed much better than I expected, with speeds staying in the double digits and maxing out around 206 MB a second on the reads and 201 MB a second on the writes at larger file sizes. Finally, it was time for HD Tune. The minimum transfer rate was 31 MB a second and the maximum 145 MB a second. Again, I'm unsure on the exact method for this test in terms of file sizes and queue count, but it seemed consistent when I ran it a few times. The access time of the RAID array was 12.1 milliseconds, which is higher than the rated time for these drives, but the age of them could explain that. Now that we have our results, let's compare. With the exception of the SEQ1MQ1T1 writes, the Raptor RAID 0 managed around 40% of the speed of the SSD. The random 4K Q1T1 was a very different story, with only 5 to 10% of the speed across the board. Atto Disk Benchmark showed only a few places where the RAID array beat the SSD, mostly in the very small file size write tests, again probably due to the cache on the hard drives, and in some of the read tests, 4MB, 12MB and 48MB. Finally, HDTune, where at most it had 35% the speed of the SSD. Access time was a massive 12,100% higher than the SSD, at 12.1 milliseconds. So what did we learn? Probably don't buy 14-year-old hard drives and put them in a RAID array, but I think you knew that already. The real lesson here is just how fast SSDs are and how they've changed the PC and laptop market. These days it's difficult to buy a new laptop or PC with a mechanical hard drive, as the boot drive anyway, but at the time that these hard drives came out, they were a game changer and allowed for much faster boot times over more traditional 5400 and 7200 RPM drive. And you want to improve your PC these days, it's probably better off to buy an SSD. Hope this was useful to someone. Thanks for watching.